Okay, math fans, our topic for today, this is Notes 16-1, Logarithmic Functions and Properties. And before we start, let me give you your joke of the day. What is the shark's favorite meal to order at the restaurant? And the answer is fish and chips. All right, our topic for today, logarithmic functions. Our goals are to change exponential expressions to logarithmic expressions and vice versa, evaluate logarithmic functions, and determine the domain of a logarithmic function and then graph it. So the first thing is, let's just talk about what a logarithm is and comparing it to an exponential function. So we've talked about exponential functions, something in the form y equals b raised to the x, where b is what we call the base, and then the x is the exponent. Now, this kind of equation, just like many of our equations, have what we call an inverse. So an exponential and a logarithmic function are inverses of each other. Remember, the idea of inverses is that if you're solving an equation, 3 times x equals 15, the way we undo multiplication is we divide by 3. If the equation is x squared equals 25, the way that we undo a square is we take the square root of both sides, because squaring and a square root are inverse operations. Multiplication and division are inverse operations. Well, exponential and logarithmic functions are inverse operations of each other. Now, remember that if we're actually solving for this, if we want to find the inverse of a function, what we first do is we switch x and y. Okay, so we switch the x and the y. So instead of y equals b raised to the x, in a logarithmic function, it would be x equals b raised to the y. Now the base is still the same. The base is b, but the exponent is now the variable y instead of the variable x. Now the thing is, with an inverse function, we want it to be y equals something. So if we have, for example, y equals x squared, when we find the inverse of that, it's y equals the square root of x. So we want it always to be y equals. The problem is that y is in the exponent. How do we get a variable out of the exponent? Now, we've actually never done this before. We can't just do like a square root or anything like that because we don't know the value of this exponent. So what we do is we rewrite this, because this is not a good form. And what this becomes is y equals, and we have the word log, L-O-G, and then I'm going to put a subscript here that's a b, and then x. And the way that we read this, y is the logarithm to the base b of x. Y is the logarithm to the base b of x. The variable y represents the exponent. So what I want you to understand here is that a logarithmic function is just another way to write the exponent. If we are evaluating this, and you'll see this, what we're trying to find is the value of the exponent. All right, so let's do a couple examples here. Change each exponential expression into a logarithmic expression. Okay, so we've got 1.2 raised to the third is equal to, and this is an m. That variable is an m. So when we write it in this format here, the base, the b, becomes this subscript. It's the log base b of x. So in this case, the base is the 1.2. The exponent is the 3, so that would be the y value. So the exponent is equal to the log base b, so log base 1.2 of m, of that value. e raised to the c is equal to 9. So the exponent is the c. That is the log base e of 9. Now, this number e has already come up in situations where we use continuous compounding. It occurs in a lot of natural situations. Log base e, there's a simpler way to write that. We write ln, or what I say ln. That is the natural log, and we'll come back to this. That's called the natural logarithm because it comes up in a lot of examples of growth and decay in nature. So if the base is e, we don't write log base e, we simplify that to ln 9. All right, example C, we've got the exponent, that's a, equals the logarithm base b, so that's base 4, of 24. Now I'm going to throw one more in here. Let's say we do 10 raised to the d is equal to 17. The exponent, d, equals the log base 10 of 17. Now this is another one. Base 10 is a very common logarithm because our number system is a base 10 system. So you might see this where they just write log 17. They don't put the base there. If that happens, we're assuming that the base is 10. Okay, so what we can do is we can take an exponential expression and then we can convert these to logarithmic. And there's going to be times where we need to do that. Now, in number 2 here, we're going to take a logarithmic expression and we're going to change that into an exponential expression.
Sorry, John. Just wanted
And I'm going to stop right now.